Ground fault circuit interrupters, or GFCIs, are crucial safety devices designed to protect against electrical shock. The National Electrical Code, or NEC, outlines specific requirements for GFCI installation in various locations. NEC 406.4d mandates GFCIs in all bathrooms, garages, and finished basements, and for outdoor receptacles. This requirement aims to minimize the risk of electrical shock in areas where moisture is likely to be present, or where contact with grounded surfaces is more probable. Garages and unfinished basements often have concrete floors and may contain appliances or tools that could create a ground fault. Outdoor receptacles are exposed to rain, snow, and other environmental factors, increasing the risk of electrical hazards. NEC 406.4e extends the GFCI requirement to crawl spaces, attics, and other areas accessible to personnel, such as laundry areas. These locations may not be frequently used, but when accessed, the potential for electrical shock remains. Laundry areas, in particular, often involve water and electrical appliances, making GFCI protection essential. NEC 406.8 specifically addresses spas and hot tubs, requiring GFCIs to protect users from the severe risk of electrocution associated with water and electrical equipment in close proximity. The presence of water significantly increases the conductivity of electricity, making GFCI protection a critical safety measure. NEC 406.12b emphasizes the accessibility of GFCIs, stipulating that they must be installed in a readily accessible location. This ensures that the GFCI can be easily tested and reset if it trips, maintaining continuous protection. The International Electrical Code, or IEC, also provides guidelines for GFCI installation. IEC 60364-4-41 requires GFCIs in all bathrooms, kitchens, laundries, outdoors, and in any area where water or moisture can be present. This standard aligns with the NEC focus on minimizing electrical shock risks in wet or damp environments. Kitchens, like bathrooms and laundries, frequently involve water and electrical appliances, increasing the potential for ground faults. IEC 60364-4-42 specifies that GFCIs must have a trip current of 30 mA or less. This threshold is designed to ensure that the GFCI trips quickly enough to prevent serious injury or death in the event of a ground fault. The lower the trip current, the more sensitive the GFCI is to ground faults, providing a higher level of protection. IEC 60364-4-43 mandates that GFCIs must be installed so that they are not subject to mechanical damage. This ensures the GFCI's continued functionality and reliability. Physical damage to a GFCI can compromise its ability to detect ground faults and protect against electrical shock. GFCIs function by detecting ground faults, which occur when current leaks back to the ground through an unintended path. This leakage can happen if the insulation on a wire is damaged, or if a person comes into contact with a live wire while also touching a grounded surface. The GFCI monitors the current flowing into and out of a circuit. Under normal conditions, these currents should be equal. However, if a ground fault occurs, some of the current will flow through the unintended path, creating an imbalance. When the GFCI detects this imbalance, it trips the circuit, cutting off the power and preventing electrical shock. GFCIs are designed to trip very quickly, typically within 25 milliseconds. This rapid response time is crucial in preventing serious injury or death. The faster the GFCI trips, the less time the person is exposed to the electrical current, reducing the severity of the shock. Regular testing of GFCIs is essential to ensure they are functioning properly. This can be done by pressing the test button on the GFCI. When the test button is pressed, it simulates a ground fault, causing the GFCI to trip. If the GFCI does not trip when the test button is pressed, it may be faulty and should be replaced. After testing, the GFCI can be reset by pressing the reset button. GFCIs are available in two primary forms: firstly, standalone devices that can be plugged into existing outlets, and secondly, built-in features and circuit breakers. Plug-in GFCIs are easy to install and can be used to protect individual outlets. GFCI circuit breakers provide protection for an entire circuit, offering broader coverage. When selecting a GFCI, it is important to choose one that is appropriate for the application. For example, outdoor GFCIs should be weather-resistant to protect against moisture and corrosion. GFCIs should also be listed by recognized testing laboratory such as Underwriters Laboratories or all to ensure they meet safety standards. Proper installation of GFCIs is crucial for their effectiveness. GFCIs should be installed by a qualified electrician who is familiar with the NEC and local electrical codes. The electrician will ensure that the GFCI is properly grounded and connected to the circuit. GFCI protection is not a substitute for safe electrical practices. It is still important to avoid contact with live wires and to use caution when working with electrical equipment. However, GFCIs provide an important layer of protection that can significantly reduce the risk of electrical shock. Here are some additional tips for working with GFCIs. Firstly, always turn off the power to the circuit before working on any electrical equipment. Secondly, use caution when working in wet or damp environments. Thirdly, never overload electrical circuits. Fourthly, replace any damaged or worn electrical cords or equipment. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. GFCIs are an essential safety device that can help protect you and your family from electrical shock. By understanding GFCI codes and following safe electrical practices, you can minimize the risk of electrical hazards in your home or workplace. The National Fire Protection Association, or NFPA, also provides resources and information on electrical safety. NFPA 70, the National Electrical Code, is the primary standard for electrical installations in the United States. It is important to stay up to date on the latest version of the NEC to ensure that your electrical installations meet current safety requirements. Electrical safety is a shared responsibility. By taking the necessary precautions and following established codes and standards, we can create a safer environment for everyone. Always consult with a qualified electrician for any electrical work to ensure it is done safely and in accordance with local codes. Ground fault protection is a critical aspect of electrical safety, and GFCIs play a vital role in preventing electrical shocks and saving lives.